Bismillahirrahmanirrahim. This video is about the calculation of bond length by using the FTIR data. I'm using the data which we have already published in one of the paper. This is a journal of Saudi Chemical Society, and the title of this paper is the photoluminescence emission behavior on the reduced band gap of iron doping in cerium oxide, silicon oxide nanocomposite, and photophysical properties. So here I will use these functional group to calculate the band gap, and we will use the IR data. That means we will use the wave number to calculate the bond length. So first I am going to show you the different equations that we will use to calculate the bond length. And the first one is there are the different methods and the way to calculate the bond length. And I am going to use the Badger rules over here. And this is the equation to calculate the bond length. Capital R over here is the bond length using the force constant, which should be in dynes per centimeter. And here K is the force constant, as I have said before, and C and D are the fitting constant, depending upon the periodic number of the bonded atoms in the periodic table. So these Cij values for cerium oxide and silicon oxide are this, and Dij values for the same functional groups are this, and you can get the relevant values from the literature. So what we are going to do over here, we will use the actually the force constant, put the value over here to get the value of the bond length. And for the force constant, we will use the Hooke's law, and the equation is given over here. This is 1 over 2 pi c k over mu under root, and here this is the force constant, and this is the wave number we will use for the specific functional group, and given you can get from the IR data, and pi is the constancy, is the velocity of light in centimeter per second, and this is the mu is the reduced mass, and it should be in kilogram of the bonded atoms, and which is determined by using this equation. And here a reduced mass in kilograms is equal to the mass 1, mass 2. That means these are m and m1 and m2 are the atomic masses of the bonded atoms. Let's suppose if this is the cerium O, and this is m1 and this is m2, and similarly this is the multiplication of the both masses, and here divided by the sum of the same masses over here. So this is the IR data. I am going to use some of the peaks which is mentioned in this paper, and I will show the different conversion of the units. So let's start with the calculation. So I am going to show you with the Excel file, so you can easily get the idea how to calculate the bond length. So this is the data, and this is the same paper which I have already mentioned before. So I am going to calculate one by one. So I will be starting with the reduced mass, how to calculate the reduced mass, and these are the different functional groups. That means this is the band which is mentioned in the paper, cerium oxide, if and the cerium is if it is bonded on the both sides with the oxygen. Again, this is another band of the cerium, and this is the oxygen bonded with the silicon, and silicon oxygen, and then oxygen bonded with the two silicon atoms. So I will be using all these bond uh, as a functional group to calculate the bond length. So the first is there are only the three atoms are given over here. One is the cerium, second is the oxygen, and third one is the silicon. So the masses in AMU for the cerium, silicon, and oxygen are given over here. So these masses are in atomic mass unit, and you have to calculate the mass in kilogram. Basically, these are the gram per mole, or similarly, 1 AMU is mean. This is the 140.12 grams per mole, and you have to calculate the mass in kilogram. And this is the conversion factor. You can calculate the by using or by multiplying this factor with the AMU, you can calculate the mass in the kilogram. And this is the actually the conversion I have shown over here. How to calculate 1 AMU will be equal to 1.6 x minus 24 gram, and it should be x minus 27 kilogram. That means you have to divide by 1000 to convert the gram to the kilogram. And similarly, you can use the unit conversion method, because EMU over given over here, this is the reverse calculation, and this is very easy to calculate to convert one unit to another unit, and I call it the unit cancellation method. And here your target is the 140 AMU. That means you have to cancel the AMU and you have to use this conversion. That means AMU must be in the denominator and 1.66 as minus 24 should be in the denominator. So when you apply this one, that means AMU will be cancelled out and you will get the mass in the gram. And further you can divide by 1000 to convert into the kilogram. So now what is the reduced mass? This is the step one, and the calculations are given over here. That means if you take this as a reference, cerium oxide, cerium mass is given over here, oxygen mass is 16 AMU, and you have to multiply by these two and divide it by the sum of the masses of this one, and you will get the value of the 14.36. Now you have to multiply with this factor to convert into the kilogram, and I have taken as the exponent minus 27 as a common, so to make the calculation easier. So these are the values for the reduced mass by using all these functional group. Now moving to the second part, and these are the peaks which are mentioned in the paper, or these are the actually the wave numbers of each of the bond. It depends on the what the vibration of the atoms of this functional group and all these functional groups, and these wave numbers are given over here. Actually, this is the data you are taking from the IR or FTIR. So now the second part is to convert the to calculate the this force constant, because this is required first, and then we will put this value in the formula to get the bond length. So this is actually the formula is this. This is the mu this, and when you get the value of the k will be equal to this. This is the direct conversion. You can take the first the square and the due to this, when you take the under root square, this will be the mu. This is the simple conversion. Now the important over here is to use the appropriate conversion unit. So this is the force constant. The value is in kilogram per second square or Newton per meter, because 1 Newton is equal to kilogram meter per second square. And here, if I will multiply meter over here, so meter divided by per meter will be cancelled out, and you will get the value of kilogram per second square. So that means kilogram per second square is equal to Newton per meter. So now what is the rest of the conversion? Here mu is the wave numbers in per centimeter as given over here. Your data is in per centimeter. C is the velocity of or the speed of light, which is in centimeter per second. There is no need to conversion into meter because these are going to be cancelled out. So m is the reduced mass in kilogram, and what is the other conversion, because here we will calculate the force constant in dynes per centimeter. So your the value is in it is in kilogram per second square, because you are using, when everything is cancelled out, you will get the unit of this in kilogram per second square, because centimeters cancel out, and this is the per centimeter, and what is left, this is the kilogram and per second square, because when you take the square of this one, this will become centimeter square per second square. So the rest unit will be kilogram per second square. So kilogram per second square, and it is the Newton per meter, as I have explained before. So this is just as a reference, because this you will take as a reference. This will make you uh, an easier way to convert one unit to another unit, and uh, this is equal to, that means 1 Newton per meter, or 1 kilogram per second square is equal to 0.001 mega dynes per centimeter. And whatever is the the figure over here, you have to multiply by this to convert this unit into mega dynes per centimeter, and this is required for the force constant. And briefly, I have mentioned over here, maybe you can take as a reference, you can stop the video and have a look on all these conversion. So very briefly, 1 Newton equal to exponent 5 dyne, and 1 mega equal to exponent 6 meter when it is the mega meter, and whether it is the mega dyne. So mega is exponent 6. So when it is the mega dyne, that means 1 mega dyne is equal to exponent 6 dynes. So uh, now I'm going to convert the units. So starting with the Newton, 1 Newton, as we have calculated over here, 1 Newton is exponent 5 dynes, and 1 megadynes is equal to exponent 6 dyne. Again, this is the unit cancellation method. This dyne will be cancelled out. What is left? Megadyne is left. And when you solve this one, this will be equal to 0.1 megadynes. Now your answer is in per meter, and you have to convert into the per centimeter. So this is 1 meter equal to 100 centimeter. Again, meter is meter cancelled out. This is in the numerator, and this is in the denominator. And what is left? Centimeter is left. So dynes per centimeter is your answer. And what is the overall figure? The value is zero point 0.1 divided by 100. This will give you 0.001 megadynes per centimeter. So this is the conversion. Actually, in short, you will use this conversion, but you must know how to convert one unit to another unit. So now moving to the calculation. If you have understood this one, now it will be very easy to convert to calculate the units. So we are actually getting the value of the force constant by using this equation. The first one is very simply, this is the nu is the wave number, and it should be as the given over there in the wave number. It is as mentioned in the this one E column. This is the wave number, and you have to multiply by each other. 500 multiply 500, this will be the value. So this will become per centimeter square. So similarly, you can do for the rest of the wave number. And now another one is the 4 is the constant, pi is the constant, and c is the constant. So the secondly, you can get the value of all these constant, and this is the pi is the 3.14, and this is the pi square. Okay, you can take the square. This is the 4, and the velocity of light is 3 exponent 10 centimeter per second. So when you solve this one, this will give you this number. And now, what is the next step? You have calculated this. You have calculated this. Now I'm going to multiply this with the this factor. That means simply I'm going to multiply the uh, this is the your factor in the this, and multiply with the this one factor 3.549, and I have taken over here, this is the 354. So what is left actually, exponent 20 is the common I am going to take over here. It depends on you whether you can use the whole number, but by taking the common, the calculation will make you and the easier, and it will give you the appropriate figure. So you can calculate any of the form. So the next is the value is the k constant. What is left over here? We have calculated the this multiply by this, and now you have to multiply with the reduced mass, and we have already calculated the reduced mass. And in the next column, I have just calculated the k value. K value now, that is the multiplication of the your the earlier calculated this value with the reduced mass, which we have calculated before, and this is giving you the number. And again, I am taking as the exponent minus 7 as the common. So whatever are the exponents, this is actually the 20, and you have look over here, this is exponent minus 27. So plus 20 minus 27 will give you the common of exponent minus 7, the rest value as given over here. So your k value is the, when you multiply the exponent minus with this figure, actually you will get the value of 211. Whatever over here is this, the unit is in kilogram per second square, and with the conversion 0.001, you have to multiply to convert this unit into megadimes per centimeter, and you will get now these are the unit in uh, the unit of the force constant in megadimes per centimeter. So you have done almost all the calculation. Now this is the third step. We are using this Badger rule, the equation to calculate the bond length, and this is the Cij and Dij. These are the fitting constant, as explained before. You can get from the literature. It depends on the location of these elements or the atoms in the periodic table. So the values for the cerium oxide and the silicon oxide Cij values are given over here, and Dij values are given over here. And now you have calculated the force constant and just put the values over here, and you can get the value of the bond length. Again, this is the one by one step, so you should not take any mistake during the conversion. And first you have to calculate this. This is calculated over here. uh, just put the value as given over here. This is 0.49. 0.49 is this divided by the k is the same as calculated here. And these are the three the same functional group cerium oxide, only the difference is in the mass. And uh, now the next four are the 0.535. This is for the silicon oxide. This is also for the silicon oxide, silicon oxide. The four for the silicon oxide and three bonds for the cerium oxide. So now you can just put the values, take the 1 over 3 of the power, or I have divided over here 1 divided by 3, and you can just take the power of 0.33, you will get the same answer. Now what is the next step? You have calculated this one, you are just adding the value of Dij with these calculations. So Dij's value are given over here. Let's suppose for the first case, the value. This is the O11 we have calculated over here. Now just adding the 1.26, and this is the value of 1.26 for the cerium oxide. And you have to do for the same for the three functional group 1.26. Now this is for the cerium oxide, and the value is 0.94, and the value is 0.94 is over here. And now this is the bond length you have calculated. This will directly give the value in the angstrom. And maybe you can calculate the average bond length, because these three for the cerium oxide, and these four are for the silicon oxide. So you can take the average of these three and average of these four to get the average bond length for the silicon oxide and the cerium oxide. So this is the way how can you calculate the bond length. And again I am moving to the paper again to show you the values. These are the values we have calculated through the Excel file, and the values are given over here, and you can match this value with the other